we found a sample, and it was, again, we're exploring in places where there were rivers and where there were lakes, and much as on Earth, we think that that's where we'd see signs of ancient life on Mars.
In September 2025, NASA announced a discovery on Mars that caught even its own scientists off guard. The Perseverance rover had been conducting routine analysis inside Jezero Crater when its instruments detected something entirely unexpected.
These craters are like opening doors into the geology of Mars.
At first, the data seemed impossible, so unusual that teams spent days verifying it before releasing any details. When NASA finally confirmed what they had found,
signs of microbial life on the Mars surface.
The news spread instantly across the world. Whatever Perseverance uncovered on Mars, it wasn't ordinary science anymore. Mars's mysterious past.
But once you can see things in that detail, it's like, whoa, I got the world, only it's the world of Mars.
For most of history, Mars looked like nothing more than a red, lifeless desert floating in the night sky. Its rusty surface and thin atmosphere gave the impression of a dead world that was frozen, silent, and empty. But as scientists began studying it closely, a different picture started to appear. Beneath that dusty shell lies the story of a planet that may have once been alive. Billions of years ago, Mars was not the frozen desert we know today. Research now suggests it was once warm, wet, and wrapped in a thicker atmosphere. Satellite images clearly show long, winding channels that resemble dried-up rivers, some stretching hundreds of kilometers across the planet. Around their ends are clear signs of ancient deltas, broad, fan-shaped layers of sediment that form when flowing rivers slow down and spread out as they empty into larger bodies of water like lakes or shallow seas.
But it looks like Mars is a much more intriguing planet than ever thought before.
Then came the clues locked inside Martian rocks. Certain minerals can only form in water, such as clays and sulfates. When NASA's orbiters scanned the planet, they detected these minerals scattered across ancient lake beds. This meant that long ago, Mars likely had stable pools of water that lasted for thousands, maybe even millions of years. And since water is the main ingredient for life as we know it, scientists began to wonder, what if Mars once supported living things? That question led to one of NASA's boldest moves. In the 1970s, the Viking landers became the first spacecraft to touch down on the Martian surface. Their mission was simple but daring: test the soil for signs of life.
Everything we were talking about doing in extremely short order by 1981, getting people on Mars.
The results were strange. The instruments detected some chemical activity that looked biological, but the findings didn't fully make sense. No one could tell if it was a sign of life or just a quirk of the Martian soil reacting to the tests. The mystery only deepened, leaving scientists with more questions than answers. Decades later, in the early 2000s, NASA sent two new explorers, Spirit and Opportunity. These rovers traveled across the dusty plains, studying rocks up close. What they found changed everything. Some of the rocks were smooth and rounded, shaped by running water. Others contained minerals that only form in wet conditions. Together, their discoveries proved beyond doubt that Mars once had water flowing across its surface, perhaps entire lakes, rivers, or even shallow seas. Then came Curiosity in 2012. This rover landed inside Jezero Crater, a place that once held an ancient lake. There it drilled into rocks and found layered sediments, giving evidence that the lake had existed for long periods of time. It also detected simple organic molecules, the basic chemical building blocks of life.
This location could be rife with possibilities for the emergence and propagation of life.
For the first time, scientists could say Mars wasn't just wet, it was habitable. When Perseverance launched in 2021, it was sent to a carefully chosen site called Jezero Crater, once home to an ancient lake. Billions of years ago, a massive river flowed from Mars's highlands into this crater, carving deep valleys and carrying minerals, sand, and organic-rich sediments along with it. As the water slowed at the crater's edge, it spread out and deposited these materials, forming a broad, fan-shaped delta that still stands today. Scientists believed that if Mars ever hosted microbial life, traces of it would be locked within those preserved delta layers. Perseverance's mission was not just to study the rocks, but to search for the chemical and mineral fingerprints of life hidden in Mars's ancient mud. Each mission brought humanity closer to answering the question that has haunted scientists for decades. If Mars once had water, could it also have had life? That question became the driving force behind NASA's next step, a hunt for chemical clues that could finally reveal whether Mars was once alive. How NASA hunts for clues?
Obvious when you say it. You can tell it's late afternoon because of the long shadows on Mars.
Yeah, it's like Earth, you know? It's not surprising.
Yeah, of course.
You can figure it out.
Finding evidence of life on another planet is one of the hardest things a human mission has ever attempted. NASA knows that Mars will not hand over its secrets easily. Its thin air, freezing temperatures, and endless dust storms have erased most of the traces of what once was. To uncover the truth, scientists rely on the most advanced detective ever built. It was a machine that can think, move, and analyze like a miniature laboratory on wheels. That machine is the Perseverance rover. On the surface, it looks like a robotic car crawling across rocks and craters, but inside it's packed with high-tech tools designed to study the planet at a microscopic level. Every camera, drill, and sensor serves a single purpose: to look for chemical evidence of life that might still be trapped inside ancient rocks. It doesn't search for living creatures. Instead, it looks for biosignatures, chemical fingerprints that life might have left behind billions of years ago.
One of these rock cross-sections is actually from a suspected Mars meteorite.
One of Perseverance's most powerful tools is spectroscopy. This technique involves shining light or lasers on rocks and studying how that light bounces back. Different minerals reflect light in unique ways, almost like fingerprints. By studying these reflections, scientists can tell what elements or compounds are present. Some minerals, like certain clays and carbonates, can trap organic molecules and protect them for ages. If Perseverance detects these materials, it becomes a sign that something interesting might be hidden inside. But the rover doesn't just scan the surface, but digs deep. Using its robotic arm, it can drill holes into the Martian ground and pull out core samples from below. These samples come from layers of rock untouched by radiation or harsh winds. That means they may still hold pure, unaltered evidence of ancient chemical reactions.
The arm is equipped with a drill to expose the unweathered surface beneath, or if the mission team wants to extract a sample from the rock,
or even traces of life. Each core is then sealed inside a titanium tube to keep it perfectly preserved for future study. Back on Earth, scientists run their own version of this search. They explore Earth's most extreme places, such as frozen deserts in Antarctica, boiling volcanic springs, and the salty flats of Chile's Atacama Desert. These are places where life barely survives, yet somehow still leaves faint traces behind in rock and soil. By studying how microbes survive and what chemical patterns they leave behind, scientists can create a reference library for what life's fingerprints might look like on Mars. When Perseverance's sensors detect something unusual, scientists compare it with what they've seen in these Earth environments. If a rock on Mars has similar chemical and physical signs to one that formed around living organisms on Earth, it raises big questions. Could the same process have happened there too?
Mars, a much better chance, for instance, to be not only a habitable place, but a place that might actually where life might have gotten a start.
Then, in early 2025, something caught their attention. Perseverance's instruments began picking up unusual readings in a region known as Neretva Vallis, an ancient river channel that once fed into Jezero Crater. The data hinted at a rock with a strange shape, an arrowhead, half buried in the red dust. Its position near the dried riverbed immediately drew interest, but its internal readings made it even more mysterious. At first glance, it looked like just another rock, but its chemical signature was completely different from anything the rover had seen before. It was as if this single formation had preserved a secret from Mars's ancient past waiting to be uncovered. That peculiar arrowhead-shaped rock found near the edge of an ancient river would soon become the center of one of NASA's biggest and most shocking discoveries. Check this out. This first topic already mentions the carbon. Then the second sun topic goes into details in full. So how do I frame the carbon part, especially the second subtopic, so it doesn't look as if I am talking about the carbon for the first time? Send answer back for how to frame this part. The findings came from the Perseverance rover's careful drilling and testing of the rock. Inside the sample, scientists found a surprisingly high level of organic carbon, the same element that makes up living things on Earth. This was not the first time carbon had been found on Mars, but what made this discovery special was how it was arranged. It didn't appear random or created by natural chemical reactions. Instead, it showed complex patterns, the kind usually linked with biological processes. Subtopic 1. The peculiar rock formation. This rock sat in a region NASA later called the Bright Angel Formation, an ancient river delta frozen in time.
Speculation about what Perseverance might find there did not include the strange rocks it's now observed.
The location made everything even more exciting. The Bright Angel Formation sits in an area that would have once been a perfect environment for life in a calm river delta filled with minerals, nutrients, and flowing water. If life ever existed on Mars, this would have been a safe haven for it. Sediments could have buried organic material quickly, sealing it away from radiation and the harsh Martian climate. The rock's sharp layered edges looked almost sculpted, as if shaped by both water and wind over ages.
It's a layer cake of stories in the record of the rocks.
Because its shape and structure resembled the cliffs of Chayava Falls in the Grand Canyon, an area on Earth sculpted by flowing water cutting through layered rock over millions of years, scientists chose the same name. They saw a clear geological parallel. Both formations were shaped by water erosion, sediment buildup, and the slow carving of channels that marked the presence of long-lost rivers. The more they studied it, the stranger it became. Initial scans showed that Chayava Falls was made of an unusual combination of clays, carbonates, and silica. On Earth, rocks containing these minerals are known for their ability to preserve microscopic life. Clays can trap organic molecules within their thin sheets, carbonates can seal them off from oxygen and decay, and silica can encase them in a glass-like shell. To planetary scientists, this was a perfect recipe for fossil preservation. If Mars had ever hosted life, this was exactly the kind of rock where it could have left its mark. But what truly grabbed their attention were the chemical patterns the rover detected inside it. Initial scans revealed traces of carbon-based compounds within the rock's mineral layers. At the time, these readings were only hints of unusual chemical signatures that didn't match the surrounding geology. Scientists noted the presence of carbon but couldn't yet determine its origin or meaning. Was it produced by ancient volcanic activity, or could it be something more? The answer wouldn't come until months later, when deeper analysis revealed what truly lay inside the sample.
We found a sample, and it was, again, we're exploring in places where there were rivers and where there were lakes, and much as on Earth.
When the rover's cameras later zoomed in, an entirely new set of details emerged. Tiny pits and nodules covered the rock's surface, some clustered together, others forming peculiar circular shapes. These features bore an uncanny resemblance to microbial fossils found in Earth's oldest rocks, the faint imprints left behind by ancient bacteria billions of years ago. Scientists remained cautious, but even the most skeptical among them couldn't ignore how familiar the patterns looked. The visual evidence alone was enough to justify taking the investigation one step further. To understand what was truly inside, Perseverance moved in for a closer inspection. Using its robotic drill, it carefully bored a small hole into the rock's side, extracting a cylindrical core from deep within. That sample, sealed inside a titanium tube to prevent contamination, became one of the most valuable objects ever collected from another planet. Though it would remain on Mars until a future return mission, the data transmitted from its sensors began to tell a remarkable story, even before the sample left the ground. As NASA's team analyzed the incoming results, patterns started to emerge that no one had anticipated. The mineral composition, the carbon signatures, and the microscopic textures all seemed to align in a way that defied ordinary geology. It was as if Mars itself had been guarding a secret for billions of years, and Perseverance had just begun to uncover it. Then came the bombshell. NASA's September 2025 announcement finally revealed what had been hidden inside that ancient rock. The discoveries reveal.
What we found was organic molecules in mudstones.
On September 12, 2025, NASA made an announcement that shook the world of science. After months of quiet analysis, they revealed that Chayava Falls contained what they called the clearest sign yet of ancient life on Mars.
A drill hole is visible where a sample was collected on 21st July 2024.
The press conference was streamed live from the Jet Propulsion Laboratory, and within minutes, headlines around the world lit up with disbelief and excitement. The findings came from the Perseverance rover's careful testing of the rock. The strange carbon signatures detected months earlier were finally decoded. Inside the core sample taken from Chayava Falls, scientists found that the carbon was not randomly distributed, but arranged in distinct chemical patterns. This organization was unlike anything seen in purely geological reactions. For the first time, the data suggested a possible biological origin, a structured form of organic carbon that hinted Mars's ancient environment may once have supported life. Under high-powered microscopes, the surface of the rock revealed odd circular marks scattered across it. They looked like tiny spots and dots pressed into the stone. The scientists gave them strange but fitting nicknames of leopard spots and poppy seeds. These were not just holes or cracks. They were layered and organized in a way that hinted at growth or colony-like structures, similar to microbial mats found in ancient rocks on Earth. The deeper analysis only made the mystery stronger. Inside these circular marks, NASA's instruments found traces of two unusual minerals, vivianite and greigite. On Earth, these minerals often form when bacteria interact with iron under waterlogged or oxygen-poor conditions. In simple terms, they are leftovers from chemical reactions driven by living organisms. The same types of minerals have been seen in Earth's oldest fossilized microbial colonies, some more than 3 billion years old.
These craters are like opening doors into the geology of Mars.
To ensure accuracy, the samples were scanned and tested using several different instruments on board Perseverance, including PIXL, Sherlock, and SuperCam. Each one confirmed the same result. The chemical fingerprints matched what scientists would expect from something that had once supported life or had been influenced by biological activity. When the data was reviewed by independent experts, it was sent for publication in Nature, one of the most respected science journals in the world. During the official announcement, the acting NASA administrator summarized the moment perfectly. He said it was the strongest evidence yet that Mars may once have hosted life.
We think that that's where we'd see signs of ancient life on Mars.
His words echoed across newsrooms, classrooms, and social media platforms. For a planet long thought to be barren and lifeless, this was groundbreaking. It suggested that billions of years ago, Mars may have been a living world with rivers, microbes, and maybe even an evolving ecosystem. But while the discovery stirred hope, it also raised eyebrows. Why this is the clearest sign yet and the controversy. After NASA's announcement, the world of science lit up with excitement and debate. The team behind the discovery was careful with their words. They avoided calling it proof of life. Instead, they described it as a biosignature, a possible trace or fingerprint of something that might have once been alive. In simple terms, it meant they had found strong hints, not absolute evidence. But there was a catch. As thrilling as the discovery sounded, science demands caution. Some experts quickly pointed out that non-biological processes could also produce similar chemical patterns. For example, volcanic gases reacting with surface minerals can sometimes form carbon-based compounds without any living organisms involved. In other cases, chemical reactions between heated water and rock, known as hydrothermal processes, can also create organic-looking residues. Since Mars once had widespread volcanic activity and evidence of ancient hot springs, these non-living explanations had to be carefully examined before any claims about past life could be made. The scientific community soon split into two sides. One group believed this was the closest humanity had ever come to finding evidence of extraterrestrial life. They said the patterns were too specific and too well organized to be random geology. They called it a milestone in astrobiology. But the other side urged restraint, calling it a false dawn. They argued that Earth-based comparisons could be misleading because Mars has a very different geological history. Skeptics pointed out that Mars's thin atmosphere, intense radiation, and freezing conditions might have triggered unique chemical reactions never seen on Earth. These reactions, they said, could easily produce carbon compounds or mineral textures that only look biological. Others suggested that meteorite impacts striking the surface could have generated high heat and pressure, rearranging the minerals into patterns that mimic biological structures. A few researchers even proposed that ancient lava flows mixing with salt-rich groundwater might explain the carbon traces and mineral layering without invoking life at all.
That we find signs that life existed on Mars, and that life is very different to the life we see here on Earth. Has a different biochemistry.
Through all the noise, NASA stayed focused. They reminded everyone that Perseverance's main goal was not to prove life, but to collect the evidence needed to answer that question properly. The next question is obvious. Has NASA truly found traces of ancient life? Or is this another case of chemistry playing tricks on human hope? Fact versus hype. Is it really life? After the excitement settled, NASA stepped forward to clear the air. The data was promising but far from final. To truly know if something once lived in that Martian rock, scientists would need to study it in laboratories here on Earth. The tools aboard Perseverance, as advanced as they are, can only go so far. They can scan for molecules, identify minerals, and take microscopic images, but they cannot perform the deep biochemical tests needed to confirm life beyond doubt. NASA knew that speculation was not enough. They needed hard evidence. That was why Perseverance drilled into the Chayava Falls rock and extracted the small, untouched piece from its interior. This sample, roughly the size of a piece of chalk sealed in a titanium tube, was named Sapphire Canyon. It is one of the most valuable objects humanity has ever collected because it might contain the first physical proof that life once existed beyond Earth. But retrieving it is far from simple. The sealed tube cannot just be sent home. Mars is millions of kilometers away and no spacecraft has ever launched from its surface. To prevent contamination both of Earth and Mars, the sample must be handled in a completely sterile and sealed process. That is why NASA's Mars Sample Return mission, planned jointly with the European Space Agency, is scheduled for the early 2030s.
Meanwhile, a joint space mission by Russia and Europe has taken the brunt of the Russian invasion into Ukraine. The European Space Agency has suspended its Mars mission.
The mission will require a robotic lander to collect the tubes from Perseverance, a small rocket to launch them into Martian orbit, and an orbiter to capture and carry them back to Earth. Every step must be automated, timed perfectly, and executed without human hands. The delay until around 2030 is due to this complexity. Designing, building, and testing multiple spacecraft capable of precise coordination on 2 planets takes years. The window for safe Earth-Mars launches only opens every 26 months, so each phase must align with planetary orbits. Even once the mission is launched, the round trip, the full journey from Earth to Mars, the collection and launch of the samples into space, and their return back to Earth will take several years to complete. Only after that long cycle of travel and retrieval will Sapphire Canyon finally arrive in a secure Earth-based containment lab for detailed study. Once it returns, scientists plan to use the most powerful tools on Earth, such as electron microscopes, laser spectrometers, and isotope analyzers to inspect it at the atomic level. They will search for patterns that only living systems can produce, such as specific carbon isotope ratios or microscopic cell-like structures trapped in the rock. Until then, NASA can only confirm that Mars had the right conditions for life: water, carbon, energy, and a protective environment. But whether that chemistry ever crossed the line into biology will remain unanswered, at least until Sapphire Canyon finally makes the long journey home. What do you about this new discovery means? Comment down below. Thanks for watching. See you in the next one.